Hello students, in this video I am going to explain what is an algorithm, what are the characteristics of an algorithm. Now let's start what is DAA. DAA nothing but design and analysis of algorithms. DAA nothing but design and analysis of algorithms. So in this subject, we will design the algorithm and then we analyze the algorithm. So that is what this subject. So now we will see what is an algorithm. So algorithm nothing but it is a step-by-step procedure to solve a particular problem or to complete a particular task. So this is the basic definition. So algorithm nothing but it is a step-by-step procedure to solve a particular problem or to complete a particular task. So this is what algorithm. Now we will see what are the characteristics of an algorithm. So there are totally 5 characteristics of the algorithm. So first one, input. So input nothing but an algorithm should take 0 or more inputs. So an algorithm, it may contain 0 input, 1 input, 2 inputs, any number of inputs or 0 inputs. So the algorithm should contain 0 or more inputs, but whatever the inputs you are taking, that should be clearly you have to define. So next one, output. So your algorithm should produce at least one output. Third characteristic is finiteness. So finiteness nothing but your algorithm should contain finite number of steps. Finite number of steps nothing but your algorithm should contain countable number of steps. If you are writing an algorithm, there is no infinite steps. Your algorithm should contain countable number of steps. For example, if you want to add 2, how you will write an algorithm? In the previous languages, you use start, then you have to read 2 values. For example, read A and B. Next, you have to add the 2 numbers A plus B. Next, you have to save that result into one variable, that is C is equal to A plus B. Next, you have to print the result, that is print C. So next, finally, you have to write stop, right? So this is what you have to write for adding 2 numbers. Start the 2 numbers and adding 2 numbers and store that result into one variable, and you have to print that result and stop. So how many steps are there in this algorithm? 1, 2, 3, 4, 5, 6. So total 6 steps. So if you are writing an algorithm, there should be countable number of steps. That is what finiteness. Finiteness nothing but finite number of steps. Your algorithm should contain finite number of steps. Means countable number of steps. The next characteristic is unambiguity or definiteness. So unambiguity or definiteness is nothing but once you are writing an algorithm, whatever the steps you are taking, that should be in clear format. There is no unambiguity statements. So for example, uh, read numbers. Read numbers nothing but how many number of inputs you have to read. Read one number, two number, three number, that you have to mention. Read numbers, this statement is not clear, right? So like this, you should not write unambiguous statements in your algorithm. Confusion statements. There is no confusion statements in your algorithm. One more example. Add 2 or 3 to x. So add 2 or 3 to x, nothing but you want to add 2 to the x or you want to add 3 to the x. Which one you want to have to add? X nothing but what? So this statement is not clear, right? So like this, you should not write confusion statements in your algorithm. Whatever the statements you are writing, that should be in clear format. So next one, fifth one, effectiveness. Effectiveness nothing but in your algorithm there is no unnecessary steps. You should not write unnecessary steps in your algorithm. For example, if you want to find a given number is even number or odd number. Finding a number is even or odd. To find out the number is even or odd, you may have so many logics, but you have to apply only one logic. One logic is enough to find out if the number is even or odd. For example, to find out a even number, you may have so many logics. For example, logic 1, if number mod 2 equal to 0, then that is even, otherwise else odd. If the remainder is 0, then that number is even, otherwise that number is odd number. And another logic is, if number between AND operator and 1, in case it returns 1, then it is odd, otherwise it is even. So in a single algorithm, you don't need to write these two logics, right? You can choose this one or this one. No need to write these two. So effectiveness, nothing but in your algorithm, you have to write only the necessary steps. You should not write unnecessary steps. So this is only the example. All are characteristics of the algorithm. So DAA nothing but design and analysis of algorithm. So algorithm nothing but it is a step-by-step procedure to solve a particular problem or to complete or to compute a particular task. So what are the characteristics of the algorithm? So there are totally 5 characteristics of the algorithm. First one, input. Input nothing but it may take 0 input, 1 input or more inputs. So output nothing but your algorithm should produce at least one output. Finiteness nothing but your algorithm should contain countable number of steps. There is no infinite steps. Fourth one is unambiguity or definiteness. Means your algorithm should contain clear statements. There is no confusion statements. For example, read numbers. Read numbers nothing but you have to mention, read how many number of inputs that you have to mention. Add 2 or 3 to x nothing but which one you have to add, either 2 or 3. So these two statements are not clear, right? So next one, effectiveness. Effectiveness nothing but you have to write only the necessary steps. You should not write unnecessary steps in your algorithm. Okay, fine. So okay students, this is the basics of DAA. What is DAA? What is an algorithm? And what are the characteristics of an algorithm? In the next video, we will see how to write an algorithm in DAA, okay, using the pseudo code.